Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. Today we've got Rishmitha and she has just completed the course Linux Basics. So what we'll see at the beginning is we'll see a demonstration of her project running on a real robot like always, and then we'll get through how she managed to do a project, and towards the end we'll get to ask you a couple of questions. So what I will do now is to hand over the platform to her so she can begin her presentation. Alright, Rishmitha, whenever you're ready.
So, okay, let's start off by demonstrating the obstacle avoider program on the technical robot here in Smart Cities Lab. So, in order to do so, first we are going to execute a few commands. So, first one, we take this. So, as you can see, we are using the source Linux command in order to run the setup.bash script in the shell itself. Next, we are using the ROS2-launch command to launch this main technical lab.launch file, which usually contains all the details about the nodes and the packages and the programs that we're going to run. So let's just run it. And okay, wait a minute. It seems I have run the 3D simulator version 2 instead of connecting to the real robot. My bad.
Alright.
Let's just close this and start it.
Okay.
The explanation is similar to what I've said before, and yes, this is the correct one. And it also opened the others. Let's just put it aside for now. And next, we are just going to run this robot interface.python file. So in order to access this, we are using this change directory command to go into the path in which it is located. And let's run this too. And in a similar fashion, we are also running the main obstacle avoider.bash script. Also the robot status. Let me just put the ROS here. So ROS is a visualization tool. It basically shows all the sensor data, also the trajectory and tracks that the robot usually takes. As you can see, our obstacle avoider program has started and it's moving forward, and right now it has detected an obstacle here, which is the wall, and it's turning left, because on the left side there is more space than the right, and that's a boundary. And yes, and it is successfully moved forward again. Let's see if it will detect the other wall. And also this statistics gives us real-time sensor data. As you can see, it's all the sensor data relating to the automatic position, orientation, and the angular velocity, also the median velocity, not the axis from the
Hi Rishmitha, can you hear me?
the second wall, and it has again taken a left.
Okay, alright. I think we lost the connection a little bit there. Okay, then. What distance did you use is your threshold?
3.
Okay, 0.3. Okay, all right.
Point 0.35.
Okay.
This experimenting with the sleep time and the distance reached to reach the speed.
Okay, so you were trying to figure out how quick will it stop before hitting the obstacle.
Yeah.
Okay, all right. And how many sectors did you take into consideration when you did your LiDAR processing data? Or
Sorry, can you come again?
when how many options does it have of going left, right, or is there is
There are 8 different cases.
okay.
And this basically works by taking the laser scans in the front, left, front, right, and also the left and right.
Okay, okay.
So yeah.
All
If you
right.
want, I can just open the code editor and we can just go in depth into the code one at a time and do some samples of things that over it.
Yeah, I think let's do that. We've seen that it's managing to avoid the obstacles, which is good. I would wish it would not keep checking so many words around them. Yeah, but it's good. It's good that it's not hitting them at all. So that's fine. Yeah, and also it's moving quite smoothly now. I think it was just the place it was that was making it struggle a little bit. All right. So can you run this in simulation before you get to the code itself? I think you will have to disconnect from the robot and
So that's again, it's just similar commands. It's just here right now instead of the real robot file, we are launching the gazebo launch. We are already in this part. Let me just disconnect the real robot if that's okay with you.
Yes, that's fine.
No space for this.
All right. Okay. Yeah, it's fine. It resets completely. So yeah, you have enough time, so you can work. Okay, now it's moving forward. All right, that's good. Okay, so can you tell me something as this happens? Which script is is outputting linear acceleration to the console.
If you're talking about this console, it would be the robot statistics.
All right.
Which is giving real-time sensor data.
And the other one?
So this one would be where we have a optical available for basket.
Mhm.
It is just showing the decision makings that the algorithm is taking.
Okay.
So currently we are moving forward. So it's about to encounter a obstacle. So next it would either show, it's most probably going to show turn back.
Okay, all right. Because of where it is, I see.
Yeah, and there we have it. It's right.
All right, all right. Okay, still turning right. Must be setting linear velocity now. Let's see. It seems he's still considering that there is more obstacles when it's left. Okay, moving forward. Right, okay, so I think you can see that it's doing more than it should in terms of looking for obstacles that are on either left or right, but it's fine. The nice thing is it's managing to avoid the obstacles. All right, so can you walk us through your code now?
Let me just stop all this process to see.
All right.
Alright, it's loaded in. So all of these are inside the Linux-based projects directory. So what do you want to start with? Let's start with the obstacle avoider.
Let's start with that one. Yes.
Sure. Yeah, so first of all, we are using the shebang line right here, and this just lets the Linux system know that this is a bash script containing different bash commands. Next, again, we are using the source command here to run this particular bash script in this file itself. So robots function bash. Let's just take a quick look at that. Here. So again, this is another bash script, and it also starts with the shebang line, and it has different getter and setter functions. That these functions encapsulate the ROS2 commands, which are used to get different sensor data from the robot interface file here. And this AWK is used to take the data and split it according to different spaces. And here the print /$4 means that the fourth one will be taken as the argument.
Okay. So you're doing argument processing in that script. Okay.
And we are just printing some strings in order for us to understand. And right here we are setting all the velocities linear and angular to 0. And yeah, as you can see here, I have taken the threshold as 0.3 meters. And then the while loop starts. So this while loop keeps on continuing until the process is terminated, either using Control Z or Control C. I usually prefer Control C. So I had to use the kill command. So
I see.
So we are getting all the 5 scan ranges and storing them in different variables. So we are taking these arguments with the help of this $2 here. And again, this is where we are using the methods we have discussed previously from the robot functions basket.
Okay.
And next, we are comparing these, especially this front left, front and front right against the threshold. So as we have seen previously in the command shell, the values we are getting from the statistics were floating point values.
Right.
I faced many challenges trying to get the syntax right. So as you can see, usually these takes normal values. I could have used arithmetic expansion, but then I later realized that it's really used for the integers. So further search led me to use this particular syntax here, especially this BC minus cell. So apparently it's a low-level mathematical language that are used inside the shell, and this minus L flag loads all the math libraries. So what this is specifically using is for the floating point comparison. So we are using the echo, which takes the value of front, left and threshold using the $sign as arguments and inputs, and it converts into the string as we have known. And this string, its output, is passed as input to this part for the floating comparison using the pipeline here.
I see.
So it's the same for the comparison against the front and front right group. And now we are going into the different case studies. So first of all, if all the front left, front and front right are not free, then it either goes left or right depending on which one is greater. So here left is showing more values and right meaning it has more space towards left, it turns left. Otherwise it turns right. And once again we are using sleep command here, as apparently it's essential just as a delay to let the communication be properly handled and for handshaking to take place. Next, once again we have set the angular velocity to 0 here, because once we have turned we have no need for the angular velocity. And same here, in this part if the front left is not free and front is not free, then front right is free, it will be turning left. Once again, once we have set the angular velocity value, we are again setting it back to 0, because we don't want the robot to keep turning in circles.
Okay.
And, similarly, there are different 6 other cases.
All right, and they all follow the same procedure.
Yes.
Right. Okay. Very, very, very nice detailed presentation. All right. So for some questions, can you go up that script, the obstacle avoider, where you sourced your function script? I want you to explain a little bit more. What is that command doing? Right. What is the purpose of that statement there?
This source.
Yes.
So yeah. Once again, source is bash command. Use it to run bash scripts in that file itself, in this shell itself. Because usually, if we were to run 2 different bash scripts, we either have to terminate one normally. If we can just use the /method to run the bash scripts, right? So either we have to open 2 different terminals to run them,
Right.
or if we were to run them in the same terminal, we have to terminate them. So this allows us to parallelly run this bash script as well as with the present bash script.
All right. Very, very nice. Well put there. Okay. The other thing I want to ask you is, you spoke about using Control Z and then having to use kill command. Can you explain what is the context? Why do you have to end up using kill command when you use Control Z to terminate your processing?
So basically, we can terminate these files either using Control C or Control Z.
Mm-hmm.
So the difference between primarily lies in the signals that this command sends to the backend process.
Mm-hmm.
Coming to the Control C, it's second, and coming to the Control Z, it's stop. So
Mm-hmm.
from what I understand, Control C completely terminates the process,
Mm-hmm.
whereas Control Z is like pausing it temporarily,
Mm-hmm.
and we can again run it using the BG background or FG foreground commands.
Right, it sends it to the
So
background, yes.
it comes down to the functionality on how we want to handle the scripts.
Mm-hmm. All right. Very nice presentation, Rashmitha. I really loved it. So, congratulations. It was quite nice, well detailed. I like the way you get through this stuff. So, you just hang on and we'll wrap it up here, okay? Alright everyone, so this was Rashmitha's presentation. A very warm congratulations to you. Very nice and clear presentation, well detailed. And I would like to encourage all those of you who would like to come and do their presentations so that they can acquire their certificates to do so. And until next time, keep pushing your ROS learning. Bye bye.